Continuing our exploration with Chapter 14, now we're going to tackle the area of polygons and circles. I can think of the concept of area using what we call a geoboard. So by using this geoboard, I'm clearly delineating different segments of area that can be measured with these little squares. So I can use the addition method to divide that area into smaller squares and then count up the number of my squares. So if I wanted to find the area of this figure, I would be going through this process to count up the little squares, and I get 19 square units. Using the rectangle method, I can construct a rectangle that encompasses the figure, meaning the figure is inside of it, and then I can work from there to just take away the extra units. Here, if I want to find the area of the figure, I can utilize any of those methods. It's a little bit easier because of the jagged nature of this one to possibly encompass it and then take that area out. So I get 4 square units. Here are some baseline things to use for converting metric units of area. So this is not the conversion we did in the previous lecture. This is specific to area. So if I want to use those conversion factors to convert from this point, I'm going to use that same unit analysis process, but I'm going to use the area conversion factors. And the same is going to be true in part B. Now, if I want to convert English units of area, then I can do that utilizing these conversion factors. And if I remember, English units would be acre or square mile. Metric units are going to be air, hectare, square kilometer. Those are not very commonly used in our mathematics classrooms, but we like to expose students whenever we can. So it's a nice learning lesson for them. Here are the conversion factors for those. So there's a lot of conversion factors here. I would have those written down in a table format to be able to use. So here we have an example of a square field that has a side of 400 meters. And then I want to find the area in the hectares. I'm going to use the appropriate unit analysis method and conversion factor to get to the final answer of 16. I'm going to do the same thing in part B, taking note of I'm not showing the units here, but if we were doing this with our students, we would want to make sure we had those units there so we could show the pattern of the units canceling out. The area of a rectangle is something we learned pretty early on, and it's going to be length times width. This is probably the area of the shape people are most comfortable with. If I'm looking at a parallelogram, which means that I don't have implied 90-degree angles at each corner, it would be the base times the height. The height is that perpendicular leg. If I have an area of a triangle, I'm going to do 1/2 the base times the height. So here are some different examples of shapes with the heights indicated on them. And we can then find the area of each shape by applying the appropriate formula. If I want to find the area of a kite, that can be a little more tricky. It's going to be 1/2 the length of D1, which is going to be the width of that kite. The width of the kite is D2. D1 is the length of the kite. And then if I have the area of a trapezoid, I'm going to do 1/2 the height, which is going to be that 90-degree angle, with times the sum of my bases. So if I apply that formula, that's going to yield these answers. Notice that our units are always square. That's really important to keep bringing up to your students because having square units is the biggest mistake in the area section. If I want the area of a regular polygon, this is more advanced for our more advanced students. It's 1/2 the apothem times the perimeter. So if I'm looking at that, it's the idea of that formula is coming from the area of a circle. That's kind of where that proof would take you. So that's why the area of a circle comes next with pi r squared. The area of a sector is very similar to what we did in the first lecture. We're just going to account for the size of the angle in relation to the entire circle and how many degrees are in a circle.